The era of high-paying tech jobs is over. I know that sounds dramatic, but if you're a developer or engineer watching your salary stagnate, watching layoffs hit people you know, wondering why the market feels so different than it did a few years ago, you're not imagining it. Something fundamental has changed, and most people in tech haven't figured out what it is yet. But here's the thing. The money didn't disappear. It just moved. And the people who understand where it went are making more than ever. 200K, 300K, 400K, companies reaching out to hire them while everyone else is struggling. And I could say that because I'm one of them. I'm one of the new AI engineers making over 200K a year. And that's the new role for developers and software engineers. When I didn't even have a CS degree, I've worked with Apple, Meta, Netflix, and Amazon. Because when you already have the skills companies are desperate for, the market doesn't feel broken. It feels wide open. So in this video, I'm going to tell you exactly what changed and how to position yourself for where the high-paying jobs actually are now. What actually happened to tech? Well, the old era of tech, basically how it worked before is you learn to code. That's good. Then you get good at software engineering. Then you make 150, 200K, 250K, and that's great. That path worked for the last 15 plus years, and it created a lot of wealth. What changed? Well, basically AI arrived, not as a tool, but as a replacement of a lot of work. So the code is becoming a commodity itself, the actual act of coding itself, because AI can actually rate it out. If AI could rate it, the value drops. The layoffs weren't random. Companies realized they needed fewer traditional developers. The roles got cut where the ones AI made redundant. Let's go over how it works now, the new era of tech. Basically, high-paying tech jobs didn't disappear. It still exists, but they evolved. The money basically moved from building software to actually implementing AI into the software itself. The new role, they're basically calling it AI engineering. Taking AI models that already exist and making them work in production. So you're not just building AI from scratch, you're making AI useful in the context of the business, making an impact on the business and bringing value that's specific to for that business itself. Why it pays more? Basically, it's massive demand right now. Every company wants AI, not just tech companies itself or the big tech companies. Every single industry wants AI, especially if they're not a big company. There's a big demand for it because typically people won't think of using AI in those other niches. Right now, it's limited supply because it's such a huge thing. You try to find people who could do this really well. And most developers don't have these skills yet. The economics are simple. Scarcity pays. So if there's so much opportunity for AI right now and getting those jobs that people are looking for it, why are traditional developers struggling right now? Well, their skills are a commodity at the moment. AI writes a code now. It's faster, it's cheaper than humans. Being good at coding isn't enough when the code writes itself. So just having that skill alone doesn't make you valuable anymore. They're following the old playbook. Basically, they're still grinding algorithms, still building resumes, still thinking credentials matters most. Like thinking of algorithms, kind of like if you memorize every equation there is out there, well, if you have like calculators and Excel and programs to do that for you, you have to understand how they work. And yes, in school, you learn all these things to understand them. But you actually being good at it, that doesn't make you valuable if you could write it by hand anymore. The same idea here. For you to actually write code by hand is not where the skills or where the value is right now. Being able to understand it is, but you writing is not the main thing. Basically, the game changed, and traditional developers didn't adapt. You might hear a lot of people complain about it. Whether you like it or not, that's the reality of it. So unless you are riding the wave of change, you're going to be swept under it. So if you want to succeed of it, you have to adapt. Basically, the traditional developers are competing for shrinking roles. Traditional software engineers' roles are basically declining. More applicants are fighting for fewer positions, and salaries are getting compressed. So yes, there are still positions are still hiring the traditional developers, but you'll see over time, whether they like it or not, companies are going to have to switch over and incorporate AI literally just to compete. If AI could rate code much faster than an army of traditional developers just writing the code, you're going to have to ascend and upgrade your skill sets to bring value in other ways, because it's just a matter of time before basically their skills is a commodity already just to be able to code, just writing code by itself and knowing algorithms. It's understanding it and putting all those together. That is where the value is. Even though traditional development jobs or positions or opportunities are shrinking, the new era actually pays more than ever. Why? Because the value shifted from writing code to actually implementing AI itself, from building from scratch to connecting existing models to real systems. The models already exist. We need people to understand them and put them together to actually bring a real business value. Value to the business that actually solves their problems. And that's what businesses are going to appreciate. You basically owning the problem and having the solution set for that. Every company wants AI features. Every company, that does not necessarily a big tech company anymore, is any company, because AI could improve many different uh, disciplines, many different industries here, but very few people can actually build them. That's where your value comes up. The demand is exploding. The supply isn't keeping up. That's the main thing. This is just simple economics, demand and supply, right? If you have a high demand and you don't have a much supply of it, then the value goes up for it. The salaries reflect this. 200K is the floor for AI engineers who actually can deliver, right? Then there's 300K, 400K for senior roles. Companies are paying premium because they have no choice. And honestly, in the long run of things, these amounts to pay for a single individual to that basically pays dividends later on, or to the company, to the business value to it, is going to seem like nothing. It's easy to justify or even to start off with this and go up if you actually deliver on these things, because there's so few people. Again, this just goes back to supply and demand, right? If there's a high demand and there's very few people supplying it and you're able to do it, then you become a lot more valuable. So we know there's huge opportunity in this space, but what AI engineering actually is. So let's go over the definition. Basically taking AI models like GPT, Claude, Gemini, etc., and making them work in production. That is the main thing, making it work in production. This is where you want the engineering part, not necessarily just researchers or developers. Yes, they're extremely important to have that, but unless you try to invent this new model or new architecture that hasn't been existed yet and try to change the world, the main thing you want to focus on, especially if you want to make money now, is AI engineering here. If you actually want to deliver and actually have an impact on companies. So building systems that are reliable, scalable, and actually useful. Like again, actual useful, practical. That's usually what engineers do, right? Actually find out what the problem is, find a solution, and actually make it work. So what does it look like? So there's RAG systems, there's agentic workflows, there's LLM integrations like large language models, there's connecting AI to company data and processes. This is what every company wants, whether they're a data company or not, like basically a big tech company or not. It could be any type of industry, and I can tell you that from experience, a lot of different industries hire just they have decades of company data that are all over the place, that are not processed, or not they're not curated or processed in a certain way that could be useful to them. And it turns out that they lose information, they can't find it easily, or they have brain drain where only one person knows this information. And if they also call it the bus factor, if that person gets hit by a bus, pretty much that information is gone. So it's extremely valuable to every company being able to connect their existing data and their processes into one place that's accessible to the company. It makes them exponentially way more efficient for this. And that's what they pay for that, right? And basically making demos into products itself. That's another thing. If you could actually demonstrate how your product works to your end user companies, that is extremely valuable to companies, because that's how you get your new customer clients and you build out your company from there, right? And why it's different, right? But basically, I mentioned earlier here, if you're a data scientist or you're a researcher, AI researcher, that again, they're very important, but what they do is basically publish papers. AI engineers actually ship products. And I could tell you, because I've worked on both sides, worked with both teams, did both sides. I've published papers, published, gotten, worked with teams that published papers, and then worked with teams that we got patents for, right? And very similar processes, except one, you get recognition in the academic world and people are like, okay, great. What researchers are trying to do is beat the benchmarks of the state of the art, which doesn't necessarily translate to anything. They're like, okay, well, this certain model gets these types of results under these metrics. Ours beat that metric. What are those metrics? Well, a lot of times they're arbitrarily set and it doesn't actually translate to the real world. Whereas in AI engineering, you actually ship a product And you'll know if a product works because did it sell, right? And did the company make money off of it? Very easy. And if your company makes money off of it, that means the AI engineer gets their bonuses, they get promotions, they are basically hailed as heroes, and they get more projects and more prestige. That's the way it works, right? So the thing is, the research is already done right now. For the last 10 years, before when you get into like deep learning or AI or data science, you had to be a researcher just because it was new. Very few people knew about it. It didn't exist. So they actually had to build out these architectures as models, get the data, figure out the workflows to make it work. But then now, the last 10 years, there's so many models, and I'm pretty sure every week, nearly every day, there's a new model of something that comes out that's super impressive and is hard to keep up. So it's not about making models as a researcher, unless you really want to go into that field. But we're talking about engineering. What we want to do is actually make them useful for companies so we could actually ship products. So really the implementation is where the money is right now. We need people who actually say, okay, these models make it useful for us, for the company, solve the business problem, bring value to us. Then as an AI engineer, you become extremely valuable and you become very important. And again, important people get what they want. Here's something a lot of people don't actually realize right now: why you don't need a computer science degree to actually get into this. And one of the main reasons is that the field is way too new. It's still being defined. There, like I mentioned earlier, there's high demand for it, and very few people skilled who could actually implement it into companies. Yes, it's for the last 10 years, there was a lot of researchers. And even when that started 10 years ago, that was still new. So people are still trying to figure out what's the best way to make architectures. And there had different frameworks. And even at the beginning, you had to make your own framework. You didn't actually have a framework. You have to build it yourself. When I started at that, like way back then, like when I had to start learning it, we actually had to code the actual model architectures yourselves in whatever language. Now you have like PyTorch or like TensorFlow for to build, so it's a lot easier to do it. But the thing is, you had to figure it out. But the thing is, you can't get a degree in something that barely existed 3 years ago. Who's going to teach you if people are still discovering it, or you have to actually build it in companies? That's usually how it works. Once it's done for a while, then people come back and learn it. So everyone is doing it right now, is self-taught. They're motivated. They learn what needed to be done and go out and get it done and learn, do the right things to learn the right skills and get in front of the right people, companies, to actually have the opportunity. And that's the thing. Companies are hiring skills, not credentials. Just because you go in and you might have a lot of people say, hey, okay, we're doing AI engineering, or we're teaching AI, and you get this certificate at the end of it. Well, the people teaching it, are they actually doing AI engineering for companies? Like for myself, like when I started doing it, is that I was faced with a business problem for companies, and they say, "Hey, solve this," and I started implementing papers, and now models already exist, and I was solving for them, and that's how I get other companies to come and ask for me to solve their problems, because it basically have a track record of doing it for companies, so they know you could get the job done. Not because they're like, oh, well, see your credentials, you look like you have a certificate. Again, a certificate or a diploma in for an industry that barely existed 3 years ago. What is the credentials basically saying? Is not based on anything. But if you're basing it on someone who's actually done it, or have the skills who've done it and prove that this works and solves real business problem, that's what they're interested in, right? And honestly, they don't care where you learn it. They just want to know, can you do it? And that's the other thing. Non-traditional backgrounds are an advantage. And I know that sounds counterintuitive, but basically, one thing, having traditional backgrounds, right? Right now, there's no outdated knowledge to unlearn. One of the things that happens when you start learning from textbooks, especially you could know, when someone's new, as a developer, or a lot of industry as well, is when they come and reciting, oh, that's not how you're supposed to do something. And you're like, why not? And they said, well, the book said so. Like, obviously, they're just reading what they were taught, never actually experienced it themselves, right? So a lot of people come in pre-programmed of how things are supposed to work, not actually experiencing it or understanding it, and kind of take that for gospel. As opposed to when you learn yourself and you actually learn based on really with companies, with real projects, you actually understand what the advantage or disadvantage of doing a solution, and why something works, even though goes against the common knowledge or how things are supposed to be done. Whereas when you learn certain things, you become really rigid. And you're like, no, that's not how it's supposed to work, and you wouldn't go out and try to learn or try to do have a different approach of things, right? The other thing is domain expertise becomes your edge. Like I'm mentioning, why it's such a big opportunity right now is that every industry realize how powerful AI is right now. And yes, big tech companies were the ones pioneering it, building out the models before. And obviously, they're a big tech companies, so you expect it out of that. But now you're seeing, oh, this actually could work in my industry. It has nothing to do with big tech. It could be something as simple as I mentioned earlier before, is that we have a lot of data for decades that are in all different places on our POS system, like our point of sale system, in our emails. We have it in like some text documents. We have some physical ones. If we could use AI to capture all that, integrate and make a brain knowledge that's available to anyone, we would actually be very useful. And that has nothing to do being a big tech company. It could be any type of company for that. It could be just a retail company or a retail chain or a franchise of that, you know? And everyone's realizing how useful it could be. It doesn't necessarily have to be super technical or super advanced for it to have a huge business impact for them. And also, your weird background is your superpowers because, especially when companies saying, okay, we want AI, but we need someone that knows our industry. That is the main thing because you could hire the most skilled AI researcher in the world to work in your industry, but if they don't know your industry, they wouldn't know what is correct, what is the pain points of the company, what you're trying to optimize, what's important, or anything like that. Whereas if you already know all that stuff, plus you know how to use AI to actually connect the dots and not only that, communicate to the stakeholders why this is valuable and tell them and people who are non-technical why it's important to them and what's the impact of it to interpret that information. That knowledge is way more powerful to be able to bridge the gap. And that's how you become important. And again, I'm going to quote the Hunger Games, Katniss' sister, where she mentioned before, important people, get what they want. And if you have these superpowers, you become very important. So basically, to give you a head start and not for you to basically have the knee jerk reaction of, let me just go start learning everything on YouTube. And you go down a rabbit hole learning a bunch of new things because you think everything's important. Let me tell you the skills that pays right now. So, first of all, the modern AI stack. Basically, if you want to get into this, learn LangChain, RAG, vector databases, agentic workflows. Understand what these are first, right? And then understand prompt engineering at scale. This is where the money is right now, right? Once you have this, you still need to know engineering fundamentals. So if you're a software developer, all these things in a real production, actually delivering a product and working with a company is still important. So that's the thing, is that what people don't realize, if you already in tech, if you already IT or DevOps or a developer, software developer, front end, back end, if you're doing like embedded systems, anything like that, you have a lot of these fundamentals because they still come into play. Because basically, you are still an engineer. You're just adding AI into the mix of it, right? So you still need to know the fundamentals, and if you don't know them or you need to brush up on them, just make sure you know these things because this is good when you're working on, especially if you're working nowadays, you have distributed development. You want to make sure you have source control of your code, Git, Docker, so you can containerize it and be able to deploy it. So you don't have the problem of, oh well, this worked on my computer, but that doesn't work on scale. You never want that. Learn how to work with APIs because there's already solutions that are already out there that if it's already there, don't reinvent the wheel. Just make it work. So understand how that works. And then cloud basics because you're going to build out your models, build out your solution, but you have to build it at scale. So you're not going to build it just on your own computer. You could containerize it, make sure you could put it on the cloud, and then you could scale it up. That's what the company wants is, that's where the value is, right? So you still need to deploy and maintain systems. So all this stuff still comes into play. You're just bringing AI into it, right? Understanding and not just prompting. So that was one of the main things, especially all of last year. One of the hot things with like vibe coding. So it seemed like people who don't know how to code all of a sudden have these superpowers and they could code for them. The problem is that there is a use and a case for that is helpful, especially for non-technical people to kind of get their ideas and brainstorm how something would work and kind of showcase it or show it to other people. But that is not deployable. That is not maintaining because you don't have the engineering fundamentals to actually make this work for a big company. You have to actually understand knowing what's happening under the hood. And this is why currently software developers or developers in different industries have this knowledge. So them understanding what's actually happening behind it and not just prompt them is what make you guys much more valuable, right? Being when things don't work, debugging when things break, basically catching when AI is wrong, and implementation with understanding is the skill here. That is what it is, not necessarily coding because AI could code it right now, but implementing it, make sure it works, and understanding why it works and how to link it back together. That's where your value is right now. So I'm going to help you out again here to one. I just told you what you should know if you want to get to AI engineering, the critical path things that will actually help you solve problems. But I also want to tell you what to skip so you don't go down a rabbit hole because you're going to see a lot of new concepts and you're like, oh, should I learn this? And you start going down a rabbit hole and kind of lose sight of your main goal, right? Right now, if you want to become an AI engineer and you want to go into development, I would avoid deep math. You don't need PhD level theory. The implementation itself, again, implementation does not require like calculus proofs. You don't have to be able to prove anything or explain exactly everything how it works. Like, for example, if you try to be a researcher, right? Yeah, you want to be able to understand this stuff because you are at that level inventing new architectures or try to improve the state of the art. But we're already working with things that already exist, so you don't need the calculus proof. You don't. Yes, you might want to understand what the purpose is and what the output is. Like, what is a back propagation, forward propagation or back propagation? The concept of it, that may be helpful for you to have that knowledge. You don't actually have to build it out yourself. That's what the researchers do. You need to just implement it, right? You don't need to build things from scratch. Models now, it's been like 10 years of like very efficient models that people have been like researchers have been aggressively refining. The models already exist. So you don't need to train them. They already exist, they're tuned, or very few work to actually tune them even more. So basically you just want to focus on using them, not creating them. So the old playbook, is basically lead code grinding, that is losing relevance now because the whole concept about the leak code was kind of for the coding interviews, the coding tests. It was a way to like standardize the skill sets of different engineers to make sure they understand these concepts and their critical thinking. Now the thing is like, can you actually implement AI and actually solve the business problem? So yes, you still need to know these things, but it's not as important as it was before in the sense that if you got this incorrect, then like, a lot of companies won't hire you. Again, a lot of the companies that are looking for AI, solutions for AI, people know how to implement them, are not deep tech companies. So they probably don't even know what leak code is. A lot of them, to tell you the truth. You might be the ones coming in as a go-to person for that. So, and that's the reality of it, right? And credential collecting doesn't matter like it used to as well. Again, this industry is so new, people want to see results of it, not just, oh, you have this certificate or you have this diploma in this. They want to see, well, what can you do? They want basically to focus on proof over what's written on your paper. They want to show like, you prove to me that you've done this before, or you have the capability of solving our business problem and actually have an impact on our business and bring value to our business as well. Okay, let's talk about how to transition. If you're a developer already in many other tech roles right now, you're not that far as you may think. You just need to add these things into your repertoire before you could go out there and actually start landing AI jobs, right? So how to transition? Step one, learn the modern stack. So basically Python for data, LangChain, RAG, vector databases. Understand what these are, right? And again, focus on implementation skills, actually getting results from it, right? And then step two, build real projects, solve actual problems, not tutorial projects. Because the problem with tutorial projects is that they are curated, everything's perfect. They tell you exactly to put these things here and everything will snap together like Lego and it'll all work out, right? Think of it as like if you're buying a Lego piece and it's already pre-designed and they tell you all the instructions, you put it together and you're like, oh, great, I'm great at building Lego. Okay. But then all of a sudden the real job is they give you just the traditional Lego generic pieces and tell you to build something just as good without any instructions or anything like that. So you have to learn with what you actually have because a lot of those Lego pieces again have very customized things and everything was predetermine and work out. That's the problem with tutorials. It will give you kind of the idea of how things work, but it's like all the friction's taken out from you, from the whole process. Whereas in real world problems, nothing works as perfectly, but yet you still have to give a result and make compromises, right? And if you're able to do real projects and get real results at the end of the day, that's what companies care about. Again, real projects, your portfolio beats your resume in a new era because you could have a resume and have all these credentials, but all you have to show is like my project did this and it solved this problem. That will catch companies' attention, right? Step three, develop a domain edge. So I mentioned earlier, AI is very powerful. Industries are looking for it, and the thing is, right now, not just deep tech or big tech are using AI. Every industry is doing it. So if you are already in a specific industry and you combine AI, that combination is that rare combination is what makes you very, very valuable because you're a specialist. You're like, oh, you know AI and you know the industry that you're applying for a business. You know exactly our pain points or or what actually is the business goal of it, what actually the definition of success things. So a specialist in that industry will win over a generalist who's just someone who knows AI and then they go into an industry they don't know. They don't know how to solve a solution if they don't even know what the problem is, right? The other thing is step four is get visible. Post your work. Let people know that the projects you build and the problems you actually solve. Yeah, and then you network in the AI space. Again, it's already a simple economics right now. There's high demand and there's so low supply. The fact that you even know it alone will already get your attention. And if you post your work and show you build real projects, people will pay attention. Companies can't hire you if you don't know you exist, right? And you want to apply basically strategically, make sure make sure you want to lead with proof. Start with here's the end result. This is the problem I solve. When someone's interested and they're like, okay, what does it take for you to solve it for my company? Right. So lead with proof, not necessarily credentials, right? And then target companies that value skills. So when you see that, okay, well, okay, we could actually solve a problem. This person is valuable to us, and we will actually pay for that skill. You want to basically target those companies to align with your goals. So let's talk about when you should be doing these things. What is the timeline? Right now, the transition is happening right now. Early movers are already benefiting from this, right? There are 200K plus roles available for people with the right skills. I could tell you that for a fact. I know people, I've got some myself, so definitely it's right now, right? What's going to happen for the next 2, 3 years? The gap's going to widen because old tech skills lose more value and AI engineering becomes more standard because again, people are into it. If you're in the role, like if you're there are very few people right now. Again, supply and demand. So the ones who know how to do it, they're going to get scooped up. But over time, people are going to learn it, and you become the gap widens. So basically, early movers have the advantage right now. The window, it's open now. But the thing is, it won't stay forever. Again, 2, 3 years, you're going to see all these things going to start normalizing, right? So more people will figure this out and the advantage shrinks over time. But if you're an early mover and you're in there deep and you already established yourself, over time, you're going to establish yourself as the authority of it and the go-to person because not only that, you're also going to have projects and credentials and experience under your belt. So people are going to go to you as to someone brand new who haven't have these experience yet. Again, the window is right now for it. If you wait on that, it's just going to be harder and harder and a lot more competition in it. So here are some things that you may be wondering. These are questions I get asked all the time when I tell them, okay, the window is right now to act. And these are things that come up all the time. First of all, they're like, well, I don't have a computer science degree. Well, the thing is, like I mentioned earlier, the new era cares about skills, the results you could bring, not credentials, right? And the other thing is, well, I'm already too far into my career to switch. The thing is, experience is your asset. That is your actual superpower. Apply AI to what you know. That combination is what actually makes you a specialist and what companies want to actually hire and make you pay attention. They're like, oh, you know this industry already and you know how to use AI. Okay, let's make this work. How could you help our company? The market is too competitive right now. Well, yes, for traditional roles, it's saturated and people are basically fighting for that. AI implementation is wide open. Again, there's a high demand for AI implementation. You could go on LinkedIn right now. You could see so many companies, especially at the beginning of 2026, that they're looking for innovation lead. These are roles that didn't even exist before, or they're taking old roles and modifying them to have AI into it because they see how powerful and how impactful it is for the company. And the other thing is AI will just keep changing. Well, yes, the fundamentals of implementation stay constant. And that's the main thing. You want to be able to implement it and own the problem. So you're the go-to person, like, hey, we need this solved. You'll go in there and solve it. They're not like, okay, well, AI is always changing. You want to be the person to get the job done. And the other thing is like, I'm not smart enough. Well, the thing is, it's about focus, not IQ. You learn the right things, as I kind of pointed out earlier on, what to focus on, what not to focus on. You're able to do those things and you could show that you could show the results for it. Plus, you already have experience in your own career right now. You actually are become really, really valuable for it. And it's not necessarily about the IQ. It's actually be able to solve the business problem for them and becoming valuable in that space. You actually have a choice right now. So your first option is basically stay in the old era. Keep following the old playbook and hope it all works out. Hope this is just a fad and it just blows over, right? Compete for shrinking roles and basically watch salaries drop. Your option number two is move to the new era, learn what the market actually pays for now, and position yourself for AI engineering. Join the side that's winning. The reality of it right now is the era of high paying tech jobs as you knew them, it's over. The old way, that's over. But the era of high paying AI jobs is just beginning. The only question is which side you're on. So, what are the next steps? Listen, right now, high paying tech jobs aren't gone, they just evolve. AI engineering is the new path. The skills are learnable. If you want the exact steps to make that move, if you want the skills, the positioning, the path to 200K plus AI role, then check out the links in the description.